Hi, in this short guide we are going to explore rarefaction analysis, which is a method used to assess clonal diversity in immune repertoire by estimating the number of unique clones you would expect to find in a smaller sample. So we are starting by adding rarefaction analysis block into the project, and here we have our settings. So we're selecting the data set that we're going to process, and we're good to go with the default settings, the number of points used for the interpolation and extrapolation, the depth of the interpolation, and whether we are going to include the extrapolation in our analysis. So let's run. And yeah, that's it. It's calculated. So basically what we have here we have a rarefaction curve. Well, first of all, I'll change the colors, the ones that I like more, and also the dot shapes. So I want to make the extrapolation part like a bold. Okay, so here we have the rarefaction curves. For every sample, we have on the x-axis the rarefaction depth. The rarefaction depth is actually the interpolated and extrapolated abundance of the sample, and on the y-axis we have the mean number of unique clonotypes that we would found in the sample if the abundance of the sample is this number on the x-axis. So first, what we have here, we have two types of dots. So the first type of dot is this interpolation. Interpolation means that the data is calculated based on the real data we have in our samples, and the extrapolation, those squares, correspond to the points on the curve that we extrapolate using SHA-1 estimator. So here we immediately see that for some samples, the mean number of unique clonotypes is almost flat, meaning that we are approaching a plateau. This indicates that the diversity of the samples is well characterized. So what we picked from the data from these two samples is actually good enough, and the sequencing depth is adequate. However, for these samples, like especially for this one, blue, we see that the number of clonotypes is still rising steeply, and the repertoire is like a much more diverse than in these samples, and the sequencing run was not deep enough to capture full complexity. So actually, this is not a surprise. This project that I am using for this rarefaction analysis is actually an antibody discovery with VHH data with the rounds of selection with the phage display. So these two samples from the top, they correspond to the pre-enriched data. So that's the initial library, and obviously the diversity there is larger. While after the phage display enrichment, we have the diversity, well, almost flat. So the key takeaways of the rarefaction analysis are the following. Rarefaction standardizes samples of different sizes to compare the clonal richness and assess if sequencing depth was adequate. The subsample sequence, the way how it is calculated by subsampling, counting unique clonotypes, and plotting the results. So the plotter means sufficient sampling, and the steep curve means undersampling. So that's basically it. Thank you, and stay tuned for the next guides.